This is Math 147, Texas A&M, Calculus Biology, I guess, Calculus 1. Practice problems for Exam 1. And now I'm going to work these problems 5b through 7. All right, so 5b is a limit. It wants the limit as x approaches 3 minus something a little bit smaller than 3 for x over x squared minus 2x minus 3. Well, if I plug in 3 over 3 squared is 9 minus 6 minus 3 is 0. It's division by 0. So it's undefined. I can't do that. So I'm going to have to do some factoring. This is x divided by, now I want numbers that multiply to -3 and add to -2. How about -3 and 1? So I get x minus 3, x plus 1. So on top, it's very close. X approaches 3. Now I can plug it in. X approaches a number a little bit smaller than 3. So it's, a little bit smaller than 3. Divided by. A little bit smaller than 3 minus 3 is a tiny, teeny negative number. And a little bit smaller than 3 plus 1 is a little bit less than 4. So as this number gets teenier and tinier, the number on the bottom, a negative number times a positive, and it's a very tiny negative, it's something like a little bit 3 over a tiny negative. The product is a tiny negative. And that is going to be negative infinity. I guess I'll write it better. Negative infinity. So let me prove that to you on good old Desmos. Let's say I have around 3 divided by a tiny negative number, -0.0000001. Look at it. It's -3 times 10 to the 9th. Now let me try this. 3 divided by negative point, even more zeros, 1. It's -3 times 10 to the 25th. This number is getting bigger and bigger and bigger. So it's going to be a very tiny negative number on the bottom, which gives you a huge negative number for the answer. So that's that one. Let me try this one. Limit as x goes to 0 of 7x. Did I say the answer? I just want to make sure it's negative infinity. 7x over x. You have to know this. I would imagine it's in the notes somewhere. The limit as x approaches 0 of sine x over x equals 1. You have to know that. Well, this isn't sine x. This is sine 7x. How am I going to fix that? Well, I can come up with another letter. Y equals 7x. And if y equals 7x, x equals y over 7. So I can rewrite this as the limit as y approaches 0 of sine y, because 7x is y, divided by, you can use any, you could have used t or a or b, whatever letter you want, divided by y over 7. Well, if I divide by a fraction, it's like multiplying by the reciprocal of the fraction. So this is equal to 7 sine y divided by y. Well, the 7 I can put out in front of the, it's just a constant. So I'm going to put limit, well, I'll just put it way out here. So it's 7 times the limit of x approaches 0 of sine y over, well, this is, hold on, I shouldn't have done that because I'm missing the y. So let me fix this. I want to make sure I'm using all the right letters here. I'll move that one way over. So it's 7 times the limit. Remember, x is now y, as y approaches 0. Well, the limit as some letter approaches 0 of sine of that letter over the letter is 1. So the limit as y approaches 0 of sine y over y is 1. This is 1. 7 times 1 is 7. Got it. All right, the next one, I need a lot of room, so I'm going to have to make more room. I'll make more room like this, and then I will copy and paste it. So this is the next one. In my printing, I turned a PDF into a image, into an image file, and it got goofy, so I'm going to have to fix it. Let me move over. Okay, So this is supposed to be, I guess I'll get rid of these to clean it up. This is supposed to be square root of x squared minus 1 minus the square root of x plus 1. So whenever I have, well, first of all, can I just substitute 1 in there? 1 squared plus 1 is 2, so this is a square root of 2 minus 1 plus 1 is 2, square root of 2 minus square root of 2, divided by 1 minus 1 is 0, square root of 2 minus square root of 2 is 0 over 0, indeterminate form. I can't just plug in the number. So now I have to do some factoring, and whenever I have a constant plus or minus a square root, or a square root plus or minus a square root, either in the denominator or numerator, I can multiply by the conjugate. So I just take it and I change the sign. And watch what happens when I do that. This is going to be a wonder of wonders. It's like great magic. Oh, wait a minute. I have to make that transparent. Like that. Okay. So I'm multiplying it by this. And remember, I have to change that sign because this is the conjugate. So where it was negative, now I have to make it positive. So that's what I'm multiplying it by. And let me again clean up this. I don't know why that came over, but that's gone. Okay, now I'm going to show you something. If I have square root, well, I'll just make a simple one. 1 plus square root of 1 times 1 minus square root of 1. I take the first term times the first term. 1 times 1 is 1. The outside times the outside, negative square root of 1 times 1 is negative square root of 1. The inside times the inside, square root of 1 times 1 is plus square root of 1. And then the last times the last, positive square root of 1 times negative square root of 1 is negative 1. Now, these won't always, cancel out, but these middle terms, I had to pause for a second, those middle terms will always cancel out. In fact, let me do this example again with a 2 just to show you how those will not, it just so happened to because I made what's inside the square root the same. So let's say this is 2. So this is 2 times 2 is 4, plus 2 times square root of 1, minus, outside times outside is minus 2 square root of 1, and then negative square root of 1 times negative square root of 1, positive square root of 1 times negative square root of 1 is negative 1. So notice the middle terms go away, and 4 minus 1 is 3. So when I multiply these on top, I'm not going to have to worry about the middle terms. On the bottom, I'm just going to leave it as it is. I'm going to do x minus 1, and it's going to be times. Oh, why isn't that? It wouldn't go where I wanted it to go. It was being truculent. I remember it's got to be plus because that's the conjugate of what was there originally. All right, I just need first times first and last times last. The middle term goes away. Square root of x plus 1 times square root of x squared plus 1 rather, times square root of x squared plus 1 times square root of x squared plus 1 is x squared plus 1. I don't have to worry about the middle terms. I just need last times last. So it's going to be minus, because of this minus sign, negative times positive is negative. Square root of x plus 1 times square root of x plus 1 is x plus 1. Now I'm going to just rewrite this on the top. It's x squared plus 1. This is minus x minus 1. I just distributed the negative sign. So the 1's go away. I've got x squared minus x. I can just factor an x out. X times x minus 1. That's what's on the top. X times x is x squared. X times negative 1 is negative x. And then on the bottom, I've got x minus 1 times x squared plus square root of x squared plus 1 plus square root of x plus 1. So now the x minus 1's cancel. And I've got the limit, as x goes to 1, of x over, I guess this time I'll copy it so I don't have to change the sign, over that, square root of x squared plus 1 times x plus 1. All right, let me substitute in 1. This is 1 over x squared plus 1, or if x is 1, is 1 plus 1 is 2, square root of 2, plus square root of 1 plus 1 is square root of 2, and square root of 2 plus square root of 2 is 2 times square root of 2. It'd be like x plus x is 2x. So this is 1 over 2 square root 2. You can leave it like that, 1 over 2 square root 2, and in fact I think that's how the instructor left it. Or you could multiply it by square root of 2 over square root of 2 to rationalize the denominator. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. 2 times 2 is 4, so it's square root of 2 over 4. So I can write it as 1 over 2 square root of 2 or square root of 2 over 4, whichever one I'd like to do. All right, that's all this zooming in and out is making me dizzy. That's this one, done. Now this one, when a limit goes to infinity or negative infinity, all I have to look at is the largest power of x in the numerator and denominator, because it goes up much faster. Like x squared goes up faster than x. X to the third goes up faster than x squared. So all that matters is whatever the coefficient and the x term. So this is x cubed, or 1x cubed, divided by negative x squared. So I'm just going to carry that negative sign to the whole thing because it's going to be negative. Now, if I have x cubed over x squared, same base to different powers, I just subtract the power on the bottom. X to the 3 minus 2 equals x to the first. So that is, all I have to evaluate is negative x. And as x goes to negative infinity, this is negative infinity equals infinity, positive infinity. So the answer to this one is infinity. All right, next one. Limit x goes to infinity of e to the negative x times sine x. If you recall, sine is a function that keeps fluctuating between, it goes up to 1 and down to negative 1. It just keeps fluctuating. So I cannot just plug infinity in. What is the sign of infinity? Well, it's negative 1, 1, negative 1, 1, negative 1, 1. It doesn't, I can't find that. So I have to do something else, and I can't really factor this. I could maybe use L'Hopital's rule with calculus, but I can also use maybe the squeeze theorem. If I can find two values above and below this value, e to the minus x sine x, that have the same limit, then the thing in the middle must have that limit as well. So remember, sine of x goes as high as 1 and as low as negative 1. Well, 1 times e to the minus x is e to the minus x. And negative 1 times e to the minus x is minus e to the minus x. Now, you have to know this, so you should memorize these functions. E to the minus x looks like that. It approaches 0. I made it look like a touch, but it doesn't. And minus e to the minus x looks like that. It also approaches 0. So minus e to the minus x is always below e to the minus x. So it's minus e to the minus x is less than e to the minus x sine x is less than e to the minus x. And again, it's because sine x could be as, the biggest sine x can be as 0. 1 rather. The biggest sine x can be as 1. 1 times e to the minus x is e to the minus x. That's the largest possible value this function can take. And the smallest possible value this function can take is negative 1 times e to the minus x, which is minus e to the minus x. So that's the smallest value. And so now let me see if I can evaluate this. As x goes to infinity, well, I can see negative e to the minus x is this one. It approaches 0, so this is 0. I don't know what this is yet. Less than e to the minus x. As e to the minus x approaches infinity, it approaches 0. Well, since it's 0 to the left of it and 0 to the right of it, it squeezes it together and it's got to be at 0. And here I will prove to you on Desmos, I've got e raised to the minus x and negative e raised to the minus x. You have to know those functions. But anyway, so that's the squeeze theorem. I find one value above, one value below, a value above, a value below, and if I can show that the limits of those are the same, the limits of what's in between must be the same. And since sine of x is at most 1 and at least negative 1, Negative e to the minus x is smaller than this value. It's the smallest possible thing this can be. And e to the minus x is larger than this value, e to the minus x sine x. So I use the squeeze theorem. All right, there's two more on this page. Let me see if I can somehow get zoomed in to the right place. Okay, find all points at which this graph is continuous. You have to know a few things about logs. The log, natural log of 1, is 0. Let me show you that on Desmos. If I put log of 1 is 0. In other words, any log, because I didn't even do natural log there, natural log of 1 is 0. Log base 7 of 1 is 0. I'll do that one. Watch this. So log of anything is equal to 0. Log base anything of 1 equals to 0. So that's one thing to know here. What's the other thing? Oh, the other thing to know is you can't have a log of 0 or a negative number. Let me show you that. I'll do log of 0, undefined. Natural log of 0, undefined. Log base 7 of 0, undefined. Boop, undefined. So you can't have log of 0. So 1 minus x, let's say it has to be greater than 0. And so I get negative 1. So x has to be less than 1 because I can't have a negative. If x is 2, 1 minus 2 is negative 1. Can't have a log of a negative. Log of a negative number is undefined. And log of 1 is 0. So this has to be x less than 1. This one is 1 plus x has to be less than 0. X is less than negative 1. Because if x is negative 1 or bigger, let's say it's negative 2. 1 plus negative 2 is negative 1. If it's negative 1, 1 plus negative 1 is 0, and I can't have the log of 0 or a negative. So x has to be less than negative 1. I think I've got that backwards, to tell you the truth. Wait a minute, let me check what I had written there. Did I have less than? Yes, 1 plus x has to be greater than 0. Well, yeah, 1 minus x has to be greater than 0. 1 plus x is greater than 0. X is greater than negative 1. All right, yeah, I think I had it backwards. So x has to be less than 1 and greater than negative 1. And it cannot be 0 because if x is 0, I'm just going to put it there. If x is 0, 1 plus 0 is 1, and the log of 1 is 0. I'd be dividing by 0 if x equals 0. So x can't be 0. X has to be less than 1. X has to be greater than minus 1. Well, how do I write that? It is negative 1, 0, and it can't equal either of those, so I have to put curvy brackets in union with 0 to 1. So that's that one. Okay? Now I've got one more. Find a value c that makes this given function continuous. Well, for this to be continuous at all values, the limit must exist. So here's where I'm looking at x is less than or equal to 1, or x is greater than 1. As x approaches 1 from the left, and as x approaches 1 from the right, they must have the same limit. And what is the limit as x approaches 1 from the left, as it's less than 1 and getting towards 1? 1 squared plus 1 is 2. So the limit here also has to be 2. As if the limit, I always do this, I combine the I and the M. Limit as x approaches a from the right equals the limit as x approaches a, oh, that's from the left, a from the right. They have to be equal. If they're equal, then it has a limit as x approaches a. So if those two are equal, it has a limit at x approaches a, and it's continuous. So that's what I have to prove. So x minus c, when x equals 1, has to equal 2, So in other words, 1 minus c equals 2. Negative c equals, I'm subtracting 1 from both sides. 2 minus 1 is 1. And if I multiply both sides by 1, by negative 1, c equals negative 1. So there's that. C has to be equal negative 1. So this would have to be x plus 1, in other words, as x is greater than 1. So at 1 it would be 2, at 2 it would be 3, etc. But anyway, c has to be equal to negative 1 is the answer that they are looking for.